Hi, everybody. Welcome to another lab session. In today's lab tutorial, we are going to learn the logistic regression. So logistic regression, compared to linear regression, is the only difference is their objective variable. So in linear regression, your objective is to predict a value of a variable, where in the logistic regression, our target variable is a binary or a category variable. So in today's lesson, we are going to only use the binary variable, like 0 and 1, like boys and girls. So here, we first need to import our data, which is the example class. So here we can see for each of the student, the record is whether a female, or their reading score, writing score, math score, and whether it is the honor student. So we want to use this for column information to predict whether this student is the owner or not. So let's plot the matrix of the variable in the data. This shows the scatter plot of each variable and shows the relationship between each variables. So like you see here, the owner. Yeah, we can see that like the female relationship with owner, the read is you can see the more score you get, the more likely you are going to be owner. That observation, that student is the owner student. So here is the general framework of how we can apply the logistic regression. So first, import the SMF from the stats model and import families. So here, to build a model, we use smf.grm, which stands for generalized linear model. And the formula here, the first part, we need to write our target variable, which is the owner. And after the slash, we put 1 here. The 1 is the means we don't want to input any other variables. Basically just a line to predict. And the data is our data frame. The family is family.binomial, which means our target variable is the binomial, follows the binomial distribution, whether 0 or 1. And the results is equal to the model.fit. Because our data is the data frame, so basically we fit all of our data inside. And we print the AIC value, which is one of the measure of the logistic regression, and we check the summary table of it. And then after we run this, we can see that this is the AIC value of this model, and we can also see that this table is what we generalized. And we can see that the p-value is 0. It means the intercept is a good measure, as a good split of our data. And we check the number of observations, for residuals, log likelihood, deviations, and all kinds of measures of our model. And similarly, we can add the variable female here to check the female relationship with the owner. And by execute this, you can see that our AIC decrease, which is a good sign because the AIC is the smaller the better. And here is our logistic regression table. We can check the p-value and for our intercept and the female. And we can see that the female is not very, it's not a good variable for us to split our honor students, because that's a little bit too big. Similarly, we can use the formula for all the female read and math together, and we can see that the math is a good variable, but the read and female is not that important. And we can see our AIC decreased dramatically, which means our model gets significantly better than the previous one. So let's move on to some explanation of the model output. First is the p-value. So the column p-value here, like this, shows the calculated p-value. So in the previous class, you may have heard that the rule of the sum of that the p-value less than 5% indicate the statistical significance of the estimate. So the p-value is the probability of seeing the result given the null hypothesis is true. So in a regression, the null hypothesis is each estimated coefficient is equal to 0. So this result indicates that the female estimated coefficient is significantly different from 0 at 8% level. Yeah, this one. And we would expect only to see a coefficient that is size about 8% of the time and with a null hypothesis. And by conventional measures, this would not be considered significant. And another thing we need to see is the coefficient estimate. So the estimate column shows, like here, this column, the estimate of our sum is a linear regression model, and the results show that the intercept is 1.471. Yeah, here. And according to our simple model, this indicates that for males, the odds are the exponential value of the negative 1.47, which is 0.23. So this is for male. Because this is female, then this is for the intercept, reflect the male's odds. And the estimated coefficient on female is 0.6. And after we apply the exponential value on this is equal to 1.81, which indicates that female odds are about 80% higher than males. Refer to the worksheet from the class, you will see that we calculate those odds from the table. And this is how we interpret our coefficient result. But if you have more variables, then you cannot simply interpret the intercept of the coefficient. And like I said before, the AIC is measures the quality of the fit of the model. And a model with lower AIC is generally considered to be better. So let's see our results. Model now is 164, which is better than we only input the female or we input nothing. Which are 223. The smaller the better. So more variable input here, the result is better. So let's do some model fitting. Like what we learned before, we can use the train test bit to split our data. And we define our X is the female, V the mass, and Y is the owner. And this time we want to use the scikit-learn's logistic regression so that we don't, so this time we don't see the table itself, but we train the model with the regression.fit with the train data and then test it with the test data. So let's see. So after we predict our predict value, then we can use the score function of our regression to see our accuracy. So here the accuracy is 0.75, means our model has the accuracy of 75%. It means 70% of the time we can predict a student is the honors or not with our test data. Another thing we need to learn is the confusion matrix. So we import confusion matrix from the scikit-learn and put our y-test and y-predict and get our confusion matrix. So here, the result telling us that we have 38 plus 7, these two numbers, correct prediction. Top left is the positive, true positive. This 7 is false positive. This 1 is the true false positive. The 14 is false negative. So in total, we have this number correct prediction and 15 incorrect prediction, 45 correct prediction. And we can also compute some F measures and support by this classification report function, and by putting in our y-test and y-predict, we can get a table. And let me explain this one by one. So the prediction, the ratio of this prediction is equal to the true positive divided by the true positive plus the false positive, where the and the prediction is integrated with the ability of the classifier not to label a sample as positive if it is a negative. And the recall is the ratio true positive divided by false positive plus the false negative. And this means this recall is integrated the ability of the classifier to find all the positive samples. The F1 score or the F beta score can be interpreted as a weighted mean of the precision and recall, where the F score reaches its best value at 1 and the worst value of 0. So now we can see we have 0.84, which is our accuracy. Accuracy to this. So F1 score is the weighted mean of the precision. And the support is the number of occurrence of each class in the y-test. And we can also check the accuracy, the Markov average, and the weighted average. So basically, this is the most important. 75% of time, we can successfully predict if this one student is on or not based on his or her mass or his gender, the gender and the reading scored. And finally, let's learn the ROC curve. So to generate ROC curve, we import the ROC score from the scikit-learn matrix, similar to the ROC curve, and use some plot. So we first use this ROC score by input our y-test and the y-prediction. So this part y-prediction to get the score of our model, and use this curve function to first put our y-test and use our model's predict probability of the x, which will be the y-predict, and then select all the rows with the first column to calculate different ratios. And then we further merge this into a ROC curve And our x-axis is the false positive ratio, and the y-axis is the true positive ratio. And finally, we show this plot. So this ROC curve is another common tool used with the binary classifier. The dotted line represents the ROC curve of a purely random classifier. Like if we input the random data, this will be the result. And a good classifier stays far away from that line as possible. For example, that's what we have here. This is our logistic regression model. And this is far away from these random sample, which means our model is good. So the far the better. In the best way is just one line at the top. It means you are fully correct prediction. And yeah, and this is how we generate the ROC curve. So that's everything for today's lesson. John will tell you more about the logistic regression in the from the statistical part or theory part in our Friday lesson. And after that, you can go back to this logistic regression lab session. And then you will better understand each of the steps. Thank you so much. Let me know if you have any questions.